In this video I'm going to walk you through the example on calculating power for a small clinical trial. The example that we have here is based on having proportions of people reaching a goal in each group, and this is similar to the two-way data that we've seen in other questions. Just know that if you are calculating power for a different study, the actual calculation will depend on what kind of test you're going to do at the end. So the power that we're doing for this example will only match this type of data, and for a different study you might need a different calculation. And this is the one that you will need for your projects. So our example says that we've got researchers looking to see if wearing a fitness tracker will help participants reach their target of 10,000 steps a day. They're going to have a control group just wearing a basic pedometer, and they're going to have a second group wearing the latest fitness tracker. The researchers expect from their previous work that 20% of the pedometer group will meet their target each day, and they think that if the fitness tracker can increase this rate to 50%, then that would be worthwhile, perhaps worth the cost of them. So the question is, if this is our goal of the study and this effect is real, what sample size do we need to be able to pick this up? What power does this sample size have? So we're going to go to Open Epi and go to Power Clinical Trial. Now you can do it the other way, put in your power and determine the sample size. I find that this tends to confuse students just a little bit because there's more information to put in. So we're going to stick with this version. If you want to look up the other version, that's fine. So in Open Epi, we're under Power Clinical Trial, and then you'll just need to click on the Enter to get the dialog to open up. So the information that we need to calculate power, we need to know the confidence level we're going to use, and normally we just set this at 95%, and this is the same as having an alpha of 0.05 or a significance cutoff of 0.05. So in a paper it might be reported as the alpha was set at 0.05, or it could be said that they used a confidence level of 95%. Equivalently with the power, they could say that they're using a beta of 0.2 or 20%, or they might say they were looking for a power of 80%. So again, there's two sides of the same coin, it all adds up to 1. So we'll leave our confidence level at 95%, and we'll think about our first group, and this, it doesn't matter which way around these are, we just call this our control group. We know that we have 50 pedometers available, so we'll type in 50, and out of those 50 we expect that 20 of them will have the outcome that we're interested in, which is reaching their target of 10,000 steps. In our second group, we have 35 fitness trackers available, and we're hoping that they will get up to 50% reaching their target each day. So that's all the information we need to put in. We need to think about this effect size that we're looking for. If we're looking for a very big effect, and this is a huge effect, if you can get a rate from 20% up to 50%, we can do that with a fairly small sample size because it's fairly easy to find. If the effect was much smaller, if the fitness trackers only had the effect of getting the 20% up to 30%, then we would need a much bigger sample size to pick that up. So let's go ahead and press calculate and look at what power this study has to find this effect. This is a repeat of the information we put in and an estimate of what the relative risk or the risk ratio might be at the end. And we have a power of 84%. So this doesn't guarantee that we will get a significant result. What it is saying is, if the effect is real and it is that big, then we've got a pretty good chance of actually finding it with our study. If the effect is smaller, we probably won't find it. So let's say we thought that actually the fitness trackers wouldn't be so effective and they would only get 30% of people to reach their goal. And we wanted to be able to find this effect, and we press calculate, we've got a much lower power, 18%. So it's much more difficult to pick up a small effect. And usually there's a bit of back and forth. If you don't have the power that you need, you then need to rethink your study, and typically you need to increase your sample size. So if we have a look here, we could let's set them both at 100. Let's say we get a whole lot more funding. We can buy as many fitness trackers and pedometers as we like. Our power is now 37%. We go 200. Power is now 63%, so we're getting closer, but you can see that we're having to raise our sample size quite a lot to get up to the power we need when we're looking for a smaller difference. Calculate 80%, so we've just gone over that 80% mark. Now probably we would want to go up even more, because this is 80% power if all of these 300 stay, 300 in each group stay in the study. If we have any dropout, that's going to affect our power. So we might actually want to bump that up by another 10% to allow for dropout. So work through that example, and then also have a look on the question about running a vitamin A twinning study in Bangladesh, and you should see that if you're looking for a really tiny effect, such as the increase of the twinning rate from 1.1% to 1.6%, that you need an absolutely massive sample size, and I'll post some answers later in the week to that question.